Hello, good morning, everybody. Thank you very much for coming. I would like to welcome everybody to our webinar. Before we begin, let's first establish some rules for this webinar so it's pleasant and useful to everybody. I would like to kindly ask everybody to turn off their microphones if they are not speaking. Also, I would like to mention that this webinar is being recorded and it will be uploaded to YouTube. So if you do not wish to be seen, please turn off your cameras. It also helps with better connection. If you have any questions, save them until the end. There will be plenty of time to answer them at the end of the webinar. Or if you would like, you can simply use the chat box to insert your question. Okay, now let me introduce today's speakers. I am very pleased to introduce Ms. Tania Hálová-Perglová, the Cross-Cutting and International Activities Section Director. Then I would like to welcome our co-organizers from KIAT, Mr. Felix Hongyol-Che, the International R&D Cooperation Team Leader, and Mr. Won-Sok Shin, International R&D Cooperation Team Researcher. I have other colleagues here with me who will help me to answer your potential questions. My name is Eva Pentel. I am from the Technology Agency of the Czech Republic, namely from the International Cooperation Department. As for today's agenda, you can see that our webinar will take around an hour and a half. After a short introduction of our organizations, we will explain to you the specific requirements of our joint call for proposals. Then you will see presentations of 2 projects from the researchers who successfully completed them. They will share their good practice with us. As a follow-up, I will present you with available matchmaking tools. And at the end, the platform will belong to the pitch makers who will present themselves and their project ideas in order to attract potential partners for their project. Now I would like to ask Tania Hálová-Perglová to say a few words.
Good morning, ladies and gentlemen. I would like to welcome you in this webinar dedicated to Korean and Czech cooperation in applied research and development. I would also like to welcome our Korean partners. This year in May, we are going to publish one of many joint call for proposals. We started to cooperate with Korea in 2015 when our first memorandum of understanding was signed. Since then, we have published many calls for joint proposals. And I hope that this year, the joint call will bring us many new projects, even though the pandemic situation in the world is very difficult. We know that this pandemic situation does not really allow to travel, to create new partnerships and to meet new possible partners. And that is also the reason why we are organizing this joint webinar, so that you can not only learn about the conditions of the joint call for proposals, but so that you can also see other ways to meet your partners, others than physically. And we really hope that it will encourage you to create new partnerships, even if you will probably meet your partners only once the project will be running. I wish you a very nice webinar. I hope that it is going to answer to all the questions that you have. And if it does not, please do not hesitate to contact us anytime so that we can help you, not only with the information regarding the proposal, but also with creating new partnerships. Enjoy.
Thank you very much, Tania. Let's move on. I will take over from here. Let me focus now on the bilateral cooperation represented by the Delta 2 program on the Czech side. Thatcher plans to announce the call with these listed locations. The territories in green are already confirmed. However, the locations in red are still undecided. We are still negotiating about their participation in this call. You can find a detailed list of locations and relevant foreign organizations on our website. We can move on to the specifics of this call. I'll begin with the basic criteria that Thatcher and KIAT have in common. The main applicant must be an enterprise on both sides. Research organizations, universities, and other enterprises can also participate as other participants. Thatcher and KIAT also allow linked and partner enterprises to submit a project. What does it mean? Let me illustrate a situation how it works for the Czech applicants. For example, Samsung Czech can submit a project together with Samsung Korea. At the same time, one more Czech enterprise, which is not linked to them, must be part of the consortium. The maximum length of project is 3 years. Thatcher and KIAT agreed on these priority areas of research. The reason these topics were chosen is because we wanted to attract projects that are simply relevant for the future. On the Korean side, projects with these topics will be preferred during the evaluation process. Wonsok, would you please explain the situation for the Korean applicants?
Thank you, Eva, for giving me opportunity to explain for the Korean applicants. There are priority technology areas for our joint R&D program, but there is no more value on the projects of the target area in Korean evaluation. We KIAT just gives extra 2 points if one of the projects is related to the target technology area. Whether the project is related to the target area is going to be determined by the experts during the evaluation. I want to emphasize that the priority area is not crucial for the project selection, and KIAT also welcome the projects in non-target areas. Thank you.
Thank you very much, Wonsok. Let me just emphasize that if your project idea doesn't match any of the listed areas, others are also welcome. Just be aware, Thatcher does not support defense and medical research. I'm going to move from what we have in common with KIAT to the conditions that only apply to the Czech applicants. We plan on the official announcement of the call on the May 12th. All the applications will have to be submitted by June 14th. By November 29th, project proposals will be evaluated. We will announce the results by November 30th. Awarded projects will have to start between January 1st and March 30th for the Czech successful applicants. The successful applicants from the Korean side would have to start with solving their projects in December 2020 already. So that's the difference. Otherwise, the timing is matching Thatcher and KIAT. Let me explain our conditions for funding. The total allocation to all the project proposals on the Czech side is 300 million crowns. That is around $13.4 million. The maximum funding intensity per project is up to 74% of total eligible costs, which means that the project consortium must provide at least 26% of the project budget. The actual intensity depends on the Czech state aid rules. I will explain those later. The maximum amount of funding per project is not specified. Thatcher and KIAT will fund the respective nationals in the selected consortia. It's not allowed to transfer funding between countries. As I said before, the maximum possible funding intensity per project is up to 74%. However, the maximum funding intensity per applicant is determined according to the state aid regulation. So if you want to know more details about the funding intensity per each applicant, you can look at the table I am just projecting. As you can see, the intensity depends on the type of the applicant and on the planned activities. I will move to how the application and evaluation processes work. Same as with the finances, the Czech part of the consortium applies in Czech Republic, while the Korean part of the consortium applies in Korea. The project proposals can only be submitted via our system ISTA. In order to finish the submission successfully, please don't forget to add also compulsory annexes, such as a sworn statement, common proposal, and other annexes connected to the project results. You will be able to find more details in the call documentation as soon as the call will be announced. The submission deadline is by July 14. Now I would like to walk you through how the evaluation process will work. First, each application will be checked formally. Then experts in the field check whether or not the project fulfills all the given criteria and give their recommendation for funding. Thatcher board has the final authority on which project will be recommended for funding. After comparing the results with our foreign partner, we announce them publicly. If the application is approved on both sides, the contracts can be signed and awarded projects can start. The evaluation criteria are set with respect to international cooperation. The criteria will be made public at the same time as the official announcement of the call. Now I would like to invite to our co-organizers from KIAT to present us their program and the call condition. So I'm gonna let the platform and stop my presentation.
Thank you, Eva. And now I'm going to start my presentation of KIAT specifications. Can you see my presentation slides?
Yes, it's okay. Thank you.
Okay. Good afternoon and good morning. I really appreciate all of you for your time here. My name is Won-Seok Shin of KIAT International Cooperation Team. I'm in charge of evaluation and management of international R&D projects between South Korea and Czech Republic. Now I'm going to talk about some KIAT specifications of 2021 joint R&D call with TACR. I want to notify that all of the specifications during the presentation are applied to Korean applicants. Please don't be confused. There are 5 main contents. And first, I'm going to introduce KIAT to all of you. KIAT, Korean Institute for Advancement of Technology, is an institution under Korean government named the Ministry of Trade, Industry, and Energy. We are a comprehensive industrial technology R&D support organization in Korea. At large, we have 3 main modules as shown on the slide. bilateral cooperation, multilateral cooperation, and infrastructure establishment, all of which aim at overseas market expansion and technology cooperation as a win-win strategy for each country. The R&D program between Korea and Czech Republic is one of the bilateral cooperation programs. And now I'm going to talk about qualifications of Korean institutions. All types of companies, including large enterprise and SMEs, are able to apply, and a company must be a leading organization. Non-profit institutions such as university and research institute are welcome to apply. Also, a company should be in operation for more than a year and has a certificate of corporate R&D center issued by the Korean government. There are some restrictions when you apply for this joint call. First, KIAT conduct redundancy review from a Korean website named NTIS. It aims to prevent from selecting some projects that have overlaps with other ongoing or R&D projects funded before. When KIAT finds out that a project has some overlaps with other projects, we require the applicant to explain the differences between them during the evaluation. Second, Korean organizations, the chiefs, and the people responsible for the project should not be restricted from a national R&D program by the end of the application date. Like as redundancy review, KIAT also check if one of them are restricted from R&D program through NTI's website. If the organization is restricted, they can apply for this joint call. However, if the person is restricted, the organization can apply without the person. And third, the participating company should be financially solvent. There are a lot of restrictions of financial statements described in Korean version of joint call. So you can find them, and please ask me later if you have questions. And also, the number of R&D projects that the researchers are simultaneously executing cannot exceed 5. Finally, there is a restriction on number of multi-R&D projects as leader company conducted by SMEs. For example, if a normal small-sized company has 3 ongoing projects as a leader company by the end of the deadline, it can apply for this joint call. However, there is some exceptions. For example, one of ongoing projects is supposed to end within 6 months after the deadline. It is not counted as ongoing projects. You can ask me later about the other exception cases in Q&A sessions. If the SMEs are marginal enterprises, the number restriction is more strict than the normal cases. From now on, let me talk about funding rules of KIAT. Total funding amount is 5 million won per year, and the project can have 3 years maximum. So you can get 1,500 million won in Korean, from the Korean side. The total cost is consisted of public funding and private cost, which is cash and in kind. There is a defined public funding ratio in Korea. Due to COVID-19, Korean government made a special funding guidelines for companies that suffer from this pandemic. It aims to let them ease the burden of private cost. For example, small-sized enterprises are originally supposed to make up public funding up to 67% of the total cost. However, after the special guidelines are defined, small companies can make up public funding amount up to 80% of the total cost. Actually, there is no change in funding amount, but it reduces the mandatory private cost for the enterprises. And now I'm going to explain about the cash ratio of private matching funds. Like the public funding ratio, cash ratio is also revised according to the COVID-19 special guidelines. As you can see on the PPT slide, the cash ratio that institutions should contribute is lowered for the SMEs. For example, small-sized companies were originally supposed to pay in cash with 40% or more of the private contribution. However, after the special guidelines, they are allowed to pay in cash with only 10% or more of the private total private cost. And now let me talk about evaluation criteria. These are the indicators for proposal evaluation. The total score is 100, but the score will be based on these 4 indicators. First, technological capacity. It consists 25 points out of 100. It means feasible project planning, importance and creativeness of the target technology, and possibilities to achieve project goals. Second, R&D capabilities. It consists 25 points out of 100. It means infrastructure and specific R&D role of each participant. Third, marketability. It is the most important part, and it consists 40 points out of 100. And it means possibility of successful commercialization. And the last one, international cooperation strategy. It consists 10 points out of 100. It means necessity and effectiveness of international cooperation. Projects scored over 70 points according to the above 4 indicators are classified as eligible. However, even projects with 70 points or higher can be excluded from the application depending on the evaluation results of the counterpart country and the budget situation. There are some disadvantages with insufficient international cooperation. If the Czech Republic institution's law is too simple, the project has a disadvantage to be selected. The consortia should be consisted of both countries' institutions with cooperative roles. Also, when it is possible to find corporate partners of the same technology in Korea, the project seems to be less attractive than others. There should be a decisive reason for the international joint R&D with Czech Republic institutions. However, if the foreign institutions play a crucial role for overseas markets, it would be great for KIAT. And also, as I explained before, there are priority technology areas for our joint R&D program, but there is no crucial value on the projects of the target area. KIAT just gives extra 2 points if one of the projects is related to the target technology area. Finally, I will introduce you how to apply for this joint call. For the application to be confirmed from both sides, it must be submitted to KIAT for Korean institutions and TACR for Czech Republic institutions. The application is closed on July 14th, and the proposals are going to be evaluated from July to November. TACR and KIAT agreed that the evaluation results will be notified on the same day in November, and the project will start in December from Korean side. The reason why Korean side starts 1 month earlier than the Czech side is related with Korean fiscal year. Since this joint call starts in 2021, KIAT should give applicants funding budget by the end of 2021. That's why we start 1 month earlier than Czech side. In order to apply for this joint call, the applicants must submit proposal and other documents online. Please be noted that offline submission is not required. You can find the online website address on the PPT slide. These are the contacts where you can get information for this joint call. For your information, someone who wants to find foreign partners for this joint call can contact Ms. Soo Kim of ED Research. ED Research supports potential applicants to find out partners and compose consortia for this project. Thank you for listening, and feel free to ask me questions by chat or speaking in the Q&A sessions later. Thank you.
Thank you very much, Wonsak, for your presentation. We have Mr. Kim Hyun-woo here, who wants to ask a question. Is that right? Okay, probably not. So we've got Mr. Hong Yeol. Would you like to ask a question?
Oh, actually, I made a mistake, but my name is
Okay.
Felix. I'm international R&D team leader, and actually welcome to this the webinar sessions. I hope to have the very potential R&D project between Korea and Czech Republic. Thank you.
Thank you very much for your kind words. Okay, we will move on. Let me just establish my screen back. I hope you can all see my screen right now. We are going to move to another part of the program. We are going to show you two case studies. Our guests will shortly describe their projects. They will explain what obstacles they needed to overcome and how applicable the results are in real life, and inspire us, revealing how they found a foreign partner. I would like to welcome Mr. Martin Smrš from the Institute of Physics of the Czech Academy of Sciences. Do we have Dr. Smrš here?
Yeah, I'm here. Thank you for...
Okay, great. So I'm gonna stop my presentation and you can share with us yours. Wait a minute. I think the platform is yours.
Yeah, okay, I'm trying. I hope you can see. Can you see the screen?
Yes, yes, we can see it now.
Yeah, the presentation, the slide, yeah? Okay.
Yeah, yeah.
First, let me introduce myself. My name is Martin Smrš, and I am a leader of the Advanced Laser Development Department from the High Center of the Institute of Physics. So I would like to introduce the results of the project we submitted in 2016. The project was on development of holmium laser. Can you see here or something? Okay, so yeah.
Excuse me, can I just ask you, Dr. Smrš, to put it into full screen? It would be nicer. Okay. Yeah. Thank you.
So I will try it once again. Okay, that should be now shared in full screen.
Yes, it's much better. Thank you.
Okay, sorry. Yeah,
no problem.
So we had 4 partners of the project in total. 2 research institutes. One at the Korean side, it was Korean Electronics Technology Institute, KIAT, from Seoul, and at the Czech side, the High Center of the Institute of Physics. And 2 companies at the Czech side, ProFiber Networking, and at the Korean side, Axel, and like a subcontractor, the Optonics. We have also one potential customer for a product of our research. That was Vontech company, which is producing medical lasers. So they were very interested in testing of the results of the project, and in case of successful study in integration of the solution to their product portfolio. The project duration was 3 years, started in November 2016 and finished by the end of 2019. And by that time, the Highlights was coordinator of the project in the first call that was possible. So we were coordinating the works between all the participants. So as I mentioned, the field of the project was optics and lasers, and the total cost on the Czech side were around €500,000 in Czech koruna, 13.5 million, the total funding. The public support was around 10 million Czech koruna, which is around 0.38 million euros. The Czech participants are, as I mentioned, Highlights, which is the research laser center established in 2012 with 100 employees. We focus on technology transfer in laser application, laser development, and we provide like a bridge between academia and industry. We try to commercialize the lasers and laser application and to bring new application into the field of the industrial lasers. So we have expertise in solid state pulse lasers, high power nonlinear optics, and etc. Our partner was ProFiber, which is a company established 2007. They are focusing on fiber optics, fiber lasers, communication networks, and providing services in fiber optics. So they can also provide metrology applications according to ISO standard and deliver fiber equipment. On the Korean side, there is an Axel company established in 2012. It's a single crystal growing company and a vendor of many world laser producers. They grow very high quality laser crystals, as you see on the photo. There are also some like furnaces for growing of the single crystal, and they focus on delivery of components for medical lasers. And the final partner was KIAT, institute established in 1991, and they focus on optoelectronics, smart technology, automotive, and they are leader in advanced electronics in Korea. The project motivation was to develop a laser system for medical application. As I mentioned, it's based on holmium doped garnets. The emission of the laser is around 2.1 micron. The advantage of this laser is, as you see on the figure here, the penetration depth of this wavelength is very small. It's highly absorbed in the water. And so then it's exceptionally good for cutting of tissues, destruction of kidney stones, for example, excellent for surgery, spinal surgery, urology. Then the bleeding is very low with use of the laser and so on. So that was the primary decision to do this project. Other applications are like LiDAR for measurement of gas concentration in air, production of EUV sources for lithography. This is like silicon wafer with electronic chips, which are, for example, used for mobile phone, or communication with satellites, which is now like very hot topic. So there were really many motivations to build such a laser. And finally, we really managed to build such a laser under the project. So it was a laser based on solid state crystal of holmium yak, based on technology of thin disk, which means the crystal is very thin in like hundreds of microns, which enables very efficient cooling of the crystal. It needs a special laser head, and such a laser can provide very high average power. Under the project, we also developed some like fiber laser part, which was the domain of ProFiber company, the Czech commercial partner. You see here some photos of that laser part, the laboratory demonstrators, and this is how the final product with higher readiness level can look like. This is a scheme of such a laser system, and the laser is producing picosecond pulses. So it really reached the goals we set in the project. We have pulses, 10,000 pulses per second, pulses with duration of 1 picosecond. We also developed thulium doped fiber laser, which is used like a source of energy for that holmium ions in the pulse laser. It's the thulium laser is continuously radiating, and the final holmium laser transforms that energy to ultra-short laser pulses. On the Korean side, the company Axel developed crystal growing technique. So they use the Czochralski method, which means that they grow the crystal, as you see here, from melted oxides. Yeah, so this is a photo of that. So they pull the crystal from the melt. They cutted the crystals, like you can see here on that figure. They polish the crystal because it's very critical for laser application, and help us with manufacturing of anti-reflective or reflective coatings on the crystal, and manufacturing of the gate medium for the laser, which is one of the most important part for the laser itself. At the Czech side, we developed the rest, the optics for the pumping, the cooling system, and the optical resonator of the laser. Yeah, so at the Korean side, the funding for Axel for development of this part was around 900 million wons in these 3 years. So under the project, at the Czech side, we submitted 3 functional samples: the high-power thulium doped fiber laser head for this thin disk laser system, and the whole picosecond thin disk laser system. The laser system was a laboratory demonstrator, so the technical readiness level, which describes the laser system, was not so high. However, we are still working also with other partners in Korea on increasing this readiness level, and the goal is to have the laser like on this photo. This is one of the product of the HiLase, however with different kind of crystals. So we are now transforming also this laser to the same form, and yeah, the goal is to offer this together with the Korean side like a final product. Yeah, so at the Korean side, the Axel company successfully developed the technology for growing of new type of holmium yak single crystal. The implementation phase continues. Yeah, after the meetings with the people from Wontech, they are interested in clinical study of the developed laser system here in Czechia. But yeah, it's going slowly, and especially now in the time of the COVID and limited contacts between the people. It's a bit problematic, yeah. So experience from the project are in fact very positive. Collaboration at the HiLase side was very smooth, also thanks to a good knowledge of the South Korea and good personal relationships between the scientists of the HiLase Center and the Korean institutes. Yeah, because yeah, even the director of the HiLase Center spent several years in South Korea. So this is excellent, this collaboration. We actually recommend during the project to meet at least once per year personally with the both participants' sides, the Korean and Czech, because it significantly boosts also personal relationships and is positive for the project. However, this is very limited in the pandemic, and my experience from other running Delta project at HiLase is that it negatively influences the project solution. The problems was a bit in different timing of deadlines on Korean and Czech side, which makes us some troubles in writing the reports. And also the grant agencies, at least the toucher on the Czech side, they don't accept reports in English language, which is a bit problem in international project, because all like the communication language is English, and everything must have been translated to the local language on both sides, which was a bit waste of time in my opinion. Yeah, the project was in fact initiated by the KIAT, the Korean Electronics Technology Institute, and they contacted HiLase, and yeah, so the core of the project were these 2 research institutes. The KIAT, they had a partner in Axel. They were interested in building the laser, and yeah, we had to found a partner on the Czech side, which was finally the Profiber company. Currently, the subcontractor of one of the tasks from the first Delta project was Optonics, which is currently our partner in other projects and other businesses. So currently, the Czech company Meopta, Highlights, and Optonics are developing new technology for multi-beam laser drilling, very fast laser drilling for customers like Samsung. So from that point of view, the project was very successful because we found new potential business partners in Korea. And also here locally, the Delta is, I think, a very good chance for local business because not only Profiber, but currently also the Kritur, the crystal growing company in Czech Republic, or Meopta and other partners in optics, they have new potential partners in Korea. So I see this like very beneficial from that project. And also, yeah, our Highlight Center, we are currently running several new Delta projects, not only with Korea, one is with Korea, but also with Japan, Brazil. I also find the administration of the project quite easy. Yeah, the reporting, everything is quite smooth and goes well. So, I don't see, in fact, many negatives on the project. It's actually very positive, and I want to thanks to both grant agencies on Czech and Korean side for enabling such a chance for us to collaborate with the Korean partners. That's it. Probably if you have any questions, please ask me. Otherwise, I will give the word back to Eva.
Thank you very much, Dr. Smrš, for your presentation and for the credits you gave to Thatcher and KIAT. We appreciate it very much. It was interesting. I would like to encourage everybody, if there is any question to Dr. Smrš, please ask now, because unfortunately, Mr. Smrš has to leave us in a short time, so then he won't be available. So if you have any question, please go ahead.
And anyway, you can also contact me at my email address or personally at the Highlights Center if you finally have a question later. So, but now I can answer it.
Yeah, that's right. We can interconnect. If you have any questions, you can also ask later, and we will send it to Dr. Smrš. Okay, thank you very much. We will move on. Let me just quickly get my presentation back. Great. So we should be on. We would like to show you the next case, the showcase. I would like to welcome Mr. Martin Čada from the Institute of Physics of the Czech Academy of Sciences, and Mr. Jaroslav Dolák from SVCS Process Innovation. They represent the Czech team. And for the Korean team, I would like to welcome Mr. Yong Sang Pak from ISAC Research. So we are very excited to hear your presentation. And let me just give you the platform. So I'll give you the word.
Okay, thank you. Thank you. And we'll try to share my presentation. Give me a second.
No problem.
Okay, I will find it. So, can you see it?
Yes, it's looking good.
Looking good, perfect. So I will start.
Excuse me, can you try to put it on full screen? So
okay, I will try. Just now. Is it all right?
No, no, sorry.
Because now I can see it in full screen now on my computer.
Aha, interesting. Did you try to press F11? Perhaps that would.
I think you should maybe share the full screen, not only the window.
No, still not okay. You can still see only not in full screen, or what's the situation now?
Right now we can see all your like screen. It's not a full screen.
Yeah, like PowerPoint application window. Yeah.
No, I press it. So no, it's really strange.
Okay, we can still read it. Okay, so yeah, no.
So once again. So now?
No.
How is it possible?
But perhaps it's not worth it to try to fight the technology. We can go ahead with the presentation. What do you think?
Okay. Let's go ahead. So my name is Martin Chada. I'm from the Institute of Physics, and in my presentation, so I would like to briefly introduce project concerning development of a new plasma-assisted atomic layer deposition system. Actually, you will see the case study of successful cooperation between Czech and Korean partners, both from industrial and academic sphere. So I will be talking mostly on the results on the Czech side and mutual collaboration. And Dr. Park, in the next presentation, aims his attention on the technical aspects of the project. So leading organizations were on the Czech side were SVCS, Process Innovation, and on the Korean side, it was the ISAC Research. Academic institutions participated as well. On the Czech side, it was the Institute of Physics of the Czech Academy of Sciences, and the Korean side, there were two institutions. It was Korea Institute of Material Science and the Korea Maritime and Ocean University. So let's go further. So question is, why did we deal with this project? No, I would say the reason was to take advantage of the strengths of all the partners and combine their capabilities in different technology sectors. For example, at the Institute of Physics, we are able to develop new plasma sources, and we have a lot of experiences with plasma diagnostics. And on the other hand, the SVCS is the leading manufacturer of, for example, gas delivery systems, precursor control systems, hardware, software control systems, furnaces, and so on. On the Korean side, the ISAC Research is highly reputed manufacturer of atomic layer deposition and plasma-assisted atomic layer deposition equipment. We can provide, for example, coating process and development and optimization of ALD processes. Moreover, Korean academic partners have a lot of experiences with development and preparation of thin films and nanostructures, especially suitable, for example, for microelectronics. And of course, they can provide useful analytical methods for thin film characterization. So I will just briefly mention about the financial support. The project was supported by Thatcher and KIAT. The project duration was for 3 years, between years 2016 and 2019, and the total costs of the project were approximately $2.2 million. The aim of the project was development of equipment for plasma-assisted atomic layer deposition on 300 millimeter in diameter substrates. So it was the key aim of the project, and to attain the goal several tasks has to be solved out. It includes, for example, a design of appropriate low temperature plasma source, which can be incorporated into new ALD process chamber. Furthermore, we've developed the plasma source that is sufficiently homogeneous and active, so it means that produces enough radicals and charged particles. It was important investigate microwave plasma source. It was surfatron and ECWR plasma, so it means we measured in detail plasma properties, which led to better understanding of the process with possibility to optimize the deposition process. Last but not least, to explore possibilities.
Mr. Smersh, sorry, Mr. Chada, we can't see the next slide. Can you please move in your presentation?
Which slide? Now, number 6 or 7? Because I see slide number 6.
We see only the first slide all the time.
First slide?
Yeah.
Or is it possible?
I'm sorry, I think you are still screening the window of the PPT application, but not the screen that you are showing. Could you please try pressing Alt and Tabulator so that maybe...
Yes, I did it, and okay, maybe I can, because I can see here in Google Meet that I am presenting, I am presenting the application, so I don't understand.
Yes, but unfortunately, we can still see only the application window with all the slides and preview of the screen.
I can also try to screen it for you.
Maybe I can I can switch off and start again. Okay, share the screen and window.
Yeah, you should share your screen with the full screen presentation. You need to select.
Okay, but I can select share full screen or a window. So I think
you should select full screen.
Okay, but I shall share full screen. Okay, now I select this, full screen, again.
Perfect, it's working now, yes.
It's working now, so great. So I stopped at slide number 6, if I remember well. So we can go further. So here you can see milestones of our project. So they were fulfilled, and you can see the evolution evolution of the project workflow. At the beginning, we started with the design of the plasma source with a gas delivery panel, and we designed the whole plasma-assisted system connected with thorough plasma diagnostics and testing. We developed also a microwave solid-state generator, and finally, we demonstrated the functional sample of the plasma-assisted ALD for substrates with diameter 100 millimeters. And finally, all the previous steps were transformed into prototype of the unique plasma-assisted atomic layer deposition system for deposition on big 300 millimeter in diameter substrates. So for successful meeting of all the goals, it is very important in our project to make full use of the synergies between all the partners or consortium partners. So Institute of Physics in this consortium can offer plasma source design. We can offer implement of plasma sources into lab scale ALD systems, and we can tune plasma assisted atomic layer deposition systems. On the other hand, ISIC research can help with design ALD process, and SVCS can offer experience with industrial scale deposition chamber design. This is very important, and they can help with gas delivery systems. And furthermore, the Korean academic partners assisted with deposition of nanostructured thin films by plasma-assisted ALD and by atomic layer etching. So the crucial benefit of the joint project supported by the Touch and KIAT recent possibility, I would say, to establish the close cooperation among all the partners. It was very important for us because it included mutual visits of high-skilled workers on partners' workplaces in Korea or in Czech Republic, and everything resulted in a successful project. And as a result, it was important and new, unique product. So I think it's all from my side. Thank you for attention. And next speaker, Dr. Park, will continue with better overview or a closer overview of the results of the project. So maybe we can leave questions after Dr. Park presentation, I think, because it's connected together, both our presentations.
I agree. Thank you very much, Dr. Chada.
So I leave the mode of the presentation, and then you can continue.
Mm-hmm. So I would kindly ask Dr. Park.
Okay, thank you.
Okay, thanks.
Okay. Okay, good afternoon and good morning. My name is Hong-Sang Park, and I'm CEO of IAC Research. We are the company that which has the business in atomic deposition equipment and coating service. So first of all, it's my pleasure to have opportunity to present about the project as an example of the success story we had together with the Czech partners. So as I personally assess this project, it was a really good experience and opportunity for us to having the co-development with SBCS and IPP teams. So, okay, please next. So let me start with the introduction of the project. The theme of the project was the development of the ALD and the ALE equipment using high-density plasma source. When we first organized this project, we had an ALD equipment and process technology and market information. Instead, SBC's case had a key core element technology of high power and high density microwave plasma generation. So I thought we can make a synergy if we combine our ALD2 technology with the SBCS plasma technology, opening up the new business markets. So that is the first thought we had when we first start this project. So as we perform the team building for this project, from Korea side, ISAC had other sub-partners such as KIMS, Korea Institute of the Material Science, and the KMOU, Korea Maritime Ocean University, which would focus on the development of the key process technology using high-density plasma process, especially on the atomic layer etching and the 2D materials growth. So in order to start this project, at first, we should learn the secure technology from each side. We have visited Czech and learned about the gigahertz level microwave plasma known as spectrum plasma. It was quite impressive knowing that the depth of the scientific backgrounds and the basic research background IPP and the SBCS has. So we found out the technical feasibility of the high-density plasma generation and got confidence that it will be a differentiation point in equipment business area and the advantage in developing new high-quality ALD films, paving the way for the new application markets. Okay, next, please. Okay. So, please next again. So by conducting the project, we have participated in designing the spectrum source development and applying it to the reactor we developed. At first, it was not simple in securing the stable and the uniform plasma condition in our reactor. So we had a lot of trouble, but we finally overcome. A lot of trial and error in setting up the equipment as shown in this slide. But we finally achieved the reactor design, and which can be applicable to the R&D level equipment. So where typically this machine is typically 4-inch and 6-inch wafer applicable. So we think that we can develop the reactor which can be used for the R&D equipment level. Okay, please next. So in securing the much larger size reactor, such as 300 millimeters, we worked together with SBCS and getting ideas to imply multiple plasma sources simultaneously at the reactor. And then through continued efforts, we were able to quite close to the final milestones in which we get the uniform overall deposition across the 300 millimeter wafer size. Okay, next, please. As I mentioned, we were able to achieve the certain deposition we are using the microwave spectrum at the 300 millimeter wafers. And also, as we estimate the performance of this process, we can compare to other plasma ALD deposition, we can get much higher growth rate, especially in the TiO2 filler case. So during the period of the co-development project with ISAC and SBCS, we attended several international conferences together and cooperated in advertising our technical achievement to the related industrial field. Okay, please next. So from ISAC side, from our case, as we finished the project, we have achieved many assets that are tangible and intangible as well. One thing clear is that we got confidence in developing the plasma-associated technology for our products' key application. We have continued our efforts not just being tied up to the original scheme of our project, but widening the scope of our knowledge and technical skills achieved through this project. We were able to achieve the new market in ALD technology by supplying our plasma ALD system to our key customers in Korea. So the right down side, the photo shows one of the examples we shipped to our customers. So comparing the 2016, when we start this project, by now we got more technical reference in penetrating the ALD equipment market, which is really benefits to us. Okay, please next. So although it is being restricted due to the pandemics, the Korea team and Czech Republic team continue the cooperation. So we had an annual joint workshop during the period of the project, and we had a mutual technical consulting and Semicon and international exhibition for attendance, and we co-organized for ALD conference exhibition as well. So we did a quite intimate relationship together with the Czech Republic team. So as I recall the time spent together with our foreign partners, SBCS, it was a really wonderful experience for me and opportunity for ISAC. So I really thanks for our partners in Czech. So thank you all.
Eva, we can't hear you. Please switch on your microphone.
Thank you very much, Peter. Thank you very much. Okay, I'll start again. I wanted to thank all the presenters for their presentations, and Thatcher and KIAT is very proud to be part of those great projects, and we hope to support many more. Okay, we are gonna move on to another part of our presentation. Let me just share my screen. Great, it looks good. We would like to present to you and introduce to you some matchmaking tools which you could use to find a partner for your project. Thatcher Partnering Tool and Starfos are online tools available for all applicants from any country. So Starfos is a database that presents data on research, development, and innovation. It enables you to do a full text search in projects supported by the government. Partnering tool is available on Thatcher's official website. I will demonstrate this tool later on. And so those two tools are for anybody who would like to have any support in finding a partner. The next tool is Enterprise Europe Network. In the Czech Republic, it's coordinated by the Technology Center, CAS, and it's aimed at the Czech applicants only. And it helps small and medium-sized enterprises to search for foreign partners for their projects within the European Union or even outside. All these services you can use for free, and you will find the relevant links for those tools in this presentation, which will be published at our website. Let me explain a few words about the Thatcher Partnering tool. It enables companies, research organizations, or other interested parties to find a partner. You can post a brief request by registering here. Make your choice. Either click at Partner Request if you have a project idea ready, or if you wish to offer your services in support of the project idea, please click at Post a Partner Offer. After clicking on one of these buttons, you will be asked to fill out a Google form. And after that, your offer will appear on the website, and other participants can contact you. In the same way, you can also search for other participants' requests and offers. You can filter through different categories, like name of the organization, type of organization, country, or keywords, whatever works better for you. Now let me introduce today's speakers in our matchmaking session. Each speaker has 2 minutes to present himself and his project idea. So first, I would like to ask Mr. Pavera to tell us a few words about his company and his projects.
Okay, so good morning for Czech participants. Good afternoon to Korea, to Korean partners. My name is David Pavera, and maybe Mr. Pentel, before I start the presentation, may I have some short question on you?
Yes, sure. Go ahead.
At the end of your presentation, from the beginning of the webinar, you have mentioned that the Technology Agency of the Czech Republic does not support medical and defense research. And
That's
if we are talking about medical research, if we are developing the transport and rehabilitation robots for patients in hospitals or for people with limited mobility, is this acceptable for this call for proposals or not?
Thank you for your question. This would be answered by Petr Matulin. Peter, would you like to answer this?
Yes, certainly. When we were speaking about medical research, it needs some explanation. We mostly do not support clinical trials, drugs and pills and medical, so to speak, solutions, but we support medical technologies. So in this case, it would be acceptable.
Okay, thank you very much for your answer, because this question was very important for me, because this would influence my presentation, which I will start now. So that's why I was asking about that. Okay, so please let me introduce our company called Robot System. My name is David Pavera. I am working as project manager in this company. We are a small private company devoting to development of the robotic systems. Mainly in the sectors of light and heavy industry. It means gripping systems, transport and manipulation robots. In the field of nuclear energetics, like transport robots for transport of the disposal canisters with spent nuclear fuel to be stored in underground geological repositories. The robots for the healthcare, as I already mentioned. So it means the transport and rehabilitation robots for seniors and people with limited mobility, and the rescue and emergency robots for days of fire and other emergency cases. We would like to find some partner in Korea, company, university, or research institute with whom we could prepare some new common research project. We would like to prefer the partner from Korea, which is devoting to the fields of artificial intelligence, autonomous navigation, and telemedicine monitoring, but of course other partners from Korea which have something to offer for us, which can find something common with us, are welcome, of course. So that is no problem. On the next slide, we will see the examples of our robotic systems. So only very short comments. In the left upper corner, you can see the transport and rehabilitation robots like robotic bed, transformable robotic bed or stretcher for transport of patients in hospitals. On the right in the right upper corner, you can see the robotic systems for nuclear energetics like robotic rail vehicle and super storage robot for storing the nuclear waste in other repositories. Or in the left down corner, you can see the emergency and rescue robots. For example, this right one with the gripping system and water jet. And in the right down corner, you see the transport and manipulation robots, mostly the transport robots in this case for the light and heavy industry. The Omni robot, the left one for the light industry, and the Creobot for the heavy industry with 10 tons load with autonomous navigation and other let's say up-to-date technologies. So that's very shortly from my side. On the first slide of my presentation, you have the contacts on me. So if you would like to cooperate with us, you are welcome, and you can contact me anytime. Thank you for your attention.
Thank you very much, Mr. Pavera. So we will move on with our pitch session. I would like to welcome Mr. Tomáš Moucha. Do we have? Yeah, we have you here. Great. The platform is yours. Please go ahead.
Hello, everybody. I would like to introduce you the activity in the research in mass transfer laboratory concerning with the hydrogen measurement device for primary coolant in nuclear power plants. It is important to measure hydrogen in primary coolant to be able to dose it properly to suppress the corrosive products of water radiolysis. First, on the first slide, you can see our first results from 15 years ago research. You can see here the long-term stability of our H meter in laboratory conditions. And after that, on the right figure, you can see the comparison of the black line and red dash line, which represent 1 week's measurement in nuclear power plant in Czech Republic, in Dukovany, in which you can see that we started by 15% higher values compared to the commercial device. And ended by 10% lower signal. So we weren't able to keep the stable signal at process conditions. Next slide, please. And after 15 years, we found that the only one producer over the world offers this measurement device. So we continued with the development. And here you can see that we obtained long-term stability at laboratory conditions sufficiently fair to fulfill the quarterly service requirements in industrial sphere. And now we are looking for industrial partner to test our new device in nuclear power plant. And if succeeded, we would like to continue with the development of the prototype of the H meter. Thank you.
Thank you very much. We are going to move. I am very pleased to introduce Mr. Hyo Jung Yu from OTS. Do we have? Yeah, great. Okay, yeah. Please go ahead.
Hello, everybody. I'm HJU and I'm working for OTS Korea. I'm an overseas business manager. We are actually manufacturing some security side of products, so we really need our product innovation. Nowadays, AI is widely spread all over the world, so we decided to adopt AI function on our products. So we need any Czech Republic company who is specialized in image analyzing and in image detection technology. We are very welcomed. Thank you very much.
Thank you very much for your presentation. Sorry, now I would like to ask Professor Jugan to share his presentation with us from his computer because there is some problem with showing this on mine. So I will leave Professor Jugan the platform.
Hello, good morning. Good afternoon, at least for those from Korea, and good morning for local ones. I hope you can see my screen.
Yeah, we can see it fine. Thank you.
Perfect. Okay, so I would like to introduce a little bit our company. So we are a private research institute dealing with development in the metals. Mainly we are dealing with developments of technology, of materials analysis, development also some new materials and new processes. So I have also some examples of activities, but anyway, what we are doing is actually we are dealing, as I mentioned already, with metals mainly. So we are proposing new chemical compositions. We can do like small casts. We can process out of those small casts. We can make sheets. We can make wires. We can make some closed dies forgings, whatever, and then we can do the analysis in that field, like mechanical testing, thermophysical measurements. And microstructure analysis together with some fracture cases and such as that. Some examples of the tasks we have done or we are running right now. So we are dealing with many kinds of industries. One of them is, for example, power industry, where we are right now developing a technological procedure for some sheet materials development, production, the dash shielding, spent fuel. we are dealing also with the biomedicine. We have several projects dealing with development of some bioimplants from teeth over knee to hips, and also now we are working on prosthesis and such a stuff. So also that's the other field of our interest, but we have some expertise. And recently, of course, as many of the others, additive manufacturing. So here we are trying, for example, like multi-materials builds, where we can change the chemical composition from one material to the other one. So we have DED system, direct energy deposition system, where we can also do some funny materials like high entropy alloys and such a stuff. So that's in the field of additive manufacturing, which brings me to the end of my presentation. So actually, we are looking for partners who might be interested in new materials and design development, optimization of new technologies, materials processing, and also some research in the field of material analysis. So that's what we are dealing with, and we would be quite happy to establish some links. We have actually extensive experiences with Delta projects. I have been running projects with China, and I have right now 3 projects with Taiwan, and 1 already finished with Taiwan as well. So this program, I think, is very beneficial, and we will be quite happy to carry on also with the partners from Korea, where we so far haven't found anyone. So please, if somebody might be interested, let me know. I would be really happy. Thank you very much for your time, and looking forward to potential collaboration. Bye-bye.
Thank you very much, Professor Jugan. This was the last pitch presentation. So we are at the end of our webinar. Thank you very much for your patience. This is the space we have for questions. So if anybody has questions, please go ahead. Yes.
I have one question with Dr. Yong-Sok Singh. Can we have the slides he presented regarding the where the addresses were mentioned to find a partner in Korea, please? Or we have some common repository we can see it? Because yeah, is it possible, please? And how can you send it to us, or is there somewhere?
Also, all these presentations will be available at our website, so you can always get back to it and find contacts and yeah.
Yeah, this one. So,
can you find the email address and the phone number?
Yes, I will take a print out, print the screen, and now it's fine. So it's good. Okay. Now it's possible. Thank you.
Okay, thank you.
So thank you very
much. Can I close the slide?
Yeah, please. Thank you.
Okay.
Okay, great. Are there any other questions? It's also possible, if you can think about something later, or you would like to go back to our webinar, we are gonna share it on YouTube, and the presentation will be also available at our website, as I said before. So if you would like to interconnect, you can also contact me or our colleagues in KIAT, and we can interconnect you.
Thank you very much. Yeah. Thank you.
So I would like to thank you, everybody, for your attendance. I hope next time we will have an opportunity to perhaps meet in person after this crazy COVID time. I know it's very difficult right now, and we are very much looking forward to many great proposals and projects from you. And I'll see you next time. Thank you very much for your attention. Bye-bye.